Okay, so real fast to review what we did yesterday on number 3. We're trying to solve these visually so we actually understand the concept of grouping and how much each x is worth, especially when it comes to fractions. I'm working on this for a while. So the way we looked at this is that for each of these x, if we're trying to find the value of one of these, like x equals, right? That's always our goal, to have one x equals. So what we do is we just split this up into 2 groups. And instead of writing a box that we're using lines right now, so if you split this up into 2 even groups, you have to split the other side up into 2 even groups. So each group gets 3 if you split them up each side. So, and that's why the answer visually is x equals positive 3. 1x has a value of 3. Then we said, well, if you work for 2x, it could probably work for a half x. So if 1 half x, according to this picture, half of this x is equal to 4, right? Well, that must mean the other half is also equal to 4, right? That means 1 whole entire x equals all of this together, right? All 8. So half of the x equals 4, a whole x equals 8. And this is for half, like 2 pieces, so 1 over 2, right? It also works for thirds. We have 3 pieces here, so we know that on this side it's showing third. 1 out of 3 of the x is equal to -2. So if this 1/3 equals -2, that must mean that this third is -2, which means 2/3 of x equals 4 negative. And we can keep on the pattern going. I do the last one. This last third is also -2. So I know the entire x has 6 negatives. Okay, so this is what we've been working on for a whole week here. We're trying to get to the place where fractions are not just a bunch of rules that you memorize to, you do this with the numerator, and you get common denominators, and you do this, and you flip it, and just a bunch of rules that have no meaning, but an actual visual way of looking at it. So as you guys are doing a bunch of equations with fractions, we're not making mistakes that don't make sense because we're trying to remember rules as opposed to understand what we're actually doing. All right, so that was the idea here. Let's see, anything else we need to go over? Maybe one of these negative x's. Go fast. So we had a negative x. Process still works the same. This is negative 1/3 x, right? Negative third of the whole x is equal to positive 6. 1, 2, 3, 4, 5, 6. Right? So that means each of these thirds of x also are 6 more. So this third is equal to positive 6, and so is this third. 2, 3, 4, 5, 6. So because of that, I know that the whole x has 6, 12, 18 x's, or 18 ones, 18 units, right? Now, the only difference about this problem when I'm going over it is that it's a negative. So if we know negative x is equal to positive 18, one last step, we want to change this to a positive x. That's what we want our final answer to be. So we just have to flip or take the inverse of both sides. So the opposite of negative x is positive x, the opposite of positive 18 would be negative 18. So just be very careful when there is a negative on the x. Just have this one more step of taking the inverse or the opposite of both sides. Okay. Now, right now, I'm only requiring you just to show this type of work right here and the visual. If you want to do the equations as well, that's fine, but really focusing on just the visual part. We're showing both because some people prefer just the equations, some people don't. Give something for everybody. Here is where we started actually drawing our own fractions. So if it's 3/4, we know we have to draw this emphasis to fourths or 4 parts. So the easiest way to do fourths is to cut in half, and I cut those halves in half. And we know 3 out of the 4. 3/4 of a negative x, another negative x, is 12 units. So if I have 12 units and I have 3 places, 3/4 here, I gotta divide those 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12. So each of these, if I break it up evenly, has 4 positives. That must mean that last 4 also has 4 positives. That means the whole negative x is equal to 4, 8, 12, 16 positive, which means the positive x is equal to 16 negative. And this is really the jump off for the back. So we can flip it over to the back and start drawing our own graphs here, showing this visually. There's nothing here at all. So on the back, we just like you to show 1/2 of x is 3 units. Now, if you have a highlighter, you can use that, or you can just shade it in like it's shaded on the front. That's fine. And then just show the correlation. Well, this half is equal to positive 3. That must mean the other half is equal to positive 3. The whole x, 1 whole x equals 6 positive. That's what we're looking for on each of these, some sort of visual representation. Showing me and showing yourself that you understand how these fractions actually work. One more, and I'll let you guys go through it the rest of the period. So 2 out of 3, so we got thirds here. So we have divided into thirds, even thirds. And 2 of those thirds together going to be 4 units. So how many for each third if 2 of them have 4 units? 2 for each, right? I got 4 units for 2 thirds. So how much will the last third have? More units. Right? How much is the whole x equal? 6. All together. So we can actually see that all 3 of these thirds right here, all of 6 are positive, so our x will be equal. So what we just did is visually solve the equation. 2/3 x equals 4, and visually you've got an answer of x equals 6. And we'll get into the algebra of this stuff and how you multiply by reciprocals and everything later on. But at least this way, you have a way of checking your answer for sure that it works every single time. And that's what we're going for. The whole idea, of course, why we're covering fractions is because it's a 5th grade standard. And in high school, you cannot be walking around saying, 4 years ago, that math in 5th grade is sure hard. And I can't do fractions. The fractions are hard. We've got to get that out of your vocabulary and switch it over to, it doesn't matter if it's a fraction, a whole number, a negative number, I can do it. Right? And this is why. I understand what fractions are. They're not just a bunch of rules, but they actually have a good visual meaning in the real world. Okay, so I'll let you guys work. Again, don't feel like you have to do this all by yourself. It's a constant thing in math where you're kind of putting yourself in a little cave by yourself, trying to do it all by yourself. That does make things more difficult. Work with each other. Know each other's names. Help each other out. If you got it all done, turn to someone, see if you can be a help, as opposed to, I'm done, let me just worry about me and think about me. Help somebody else. I'll probably enjoy it. Okay? All right, go to work. We'll be walking around.